stand in the northern plains of India today, and the geography feels eternal. To the north, the Himalayas form an impenetrable, towering wall of rock and ice. From their peaks, massive river systems, the Ganges, the Indus, and the Brahmaputra, flow downward to quench the thirst of hundreds of millions of people. Look further south, and the Western Ghats stretch along the coast like a massive fortress. When the seasonal monsoon winds sweep in from the Arabian Sea, this mountain range catches the moisture, forcing it upward to cool and condense, bathing the entire southern peninsula in life-giving rain. But if we rewind the clock 200 million years, every single one of these geographical constants vanishes. The landmass that holds these mountains and rivers was nowhere near Asia. It was submerged deep in the southern hemisphere, surrounded by an ancient ocean. The map of India we rely on today is an illusion of permanence. It is a single, temporary frame caught at the end of a violent 9,000-kilometer geological journey. Before it was an independent peninsula, India was locked inside a colossal supercontinent known as Gondwana. It was fused tightly against landmasses that seem entirely alien to it today: Madagascar, Antarctica, and Australia. We actually derive the term for this ancient supercontinent straight from the soil of central India. The name Gondwana honors the Gond tribe, who still live among the ancient rock formations where the foundational evidence of this supercontinent was first identified. Getting the scientific community to accept this ancient planetary arrangement required a massive fight. In 1912, a German scientist named Alfred Wegener proposed the theory of continental drift, arguing that the Earth's landmasses were moving. Wegener backed his highly controversial theory with hard biological evidence. He pointed to fossils of the Mesosaurus, an ancient aquatic reptile. Identical skeletal remains of this creature were found scattered across coastlines, now separated by thousands of miles of deadly, uncrossable oceans. The scattered bones proved a terrifying reality. The crust beneath our feet is not a solid foundation. It is a chaotic collection of drifting rafts. Around 140 million years ago, the heat trapped inside the Earth's core began boiling the mantle above it, creating massive convection currents. These deep, swirling rivers of magma pushed against the underside of Gondwana until the stress fractured the supercontinent. The Indian landmass tore away from its southern neighbors. Surrounded by water, it began a lonely, northward drift into the vast Tethys Sea. This data visualization highlights an anomaly that baffled geologists for decades. Typical continental plates drift at a sluggish 4 to 5 centimeters per year. The Indian plate, however, accelerated to a massive 15 to 20 centimeters annually. Searing columns of rock, called mantle plumes, burned away the deep rock beneath the Indian subcontinent. This subterranean blowtorch reduced the plate's thickness to a mere 80 to 100 kilometers, less than half the thickness of a typical continent. Stripped of its deep, heavy anchor, the Indian plate became exceptionally buoyant. This extreme loss of mass transformed the entire subcontinent into a hyperspeed tectonic projectile aimed directly at the underbelly of Asia. As India violently tore itself away from Madagascar, upwelling magma spilled out along its newly exposed western edge. Over millions of years, this liquid rock cooled and hardened, layer upon layer. That towering wall of volcanic rock is the Western Ghats, the exact geographical feature that traps the monsoon rains and keeps southern India lush and fertile today, was born from the violent separation of two continents. Fast forward to roughly 66 million years ago. As the fast-moving Indian plate raced north, it passed directly over a massive thermal anomaly deep in the Earth known as the Reunion Hotspot. The heat punched through the thin Indian crust, creating the Deccan Traps. This million-year volcanic nightmare pumped enough sulfur and ash into the atmosphere to acidify the oceans and trigger a period of intense global cooling, severely stressing the world's biosphere. Looking at the boundary map of the Chicxulub crater in Mexico reveals a grim coincidence. When that infamous asteroid struck, it hit a planet already struggling under the weight of India's volcanic toxins. The subcontinent's violent transit acted as a global destabilizer. By poisoning the environment for millennia before the asteroid's arrival, the Indian plate provided the environmental pressure that ensured the end of the dinosaur era. Around 50 million years ago, India's 9,000-kilometer oceanic sprint abruptly ended. The continent slammed head-on into the massive Eurasian plate. Because both of these continental plates were buoyant, neither landmass could slide down into the Earth's mantle. The rock had nowhere to go but up. The immense kinetic energy of the crash folded the Earth's crust into the sky. This single brutal collision forged the highest jagged peaks on the planet, the Himalayas. This extreme new altitude pierced the atmosphere, catching and trapping moisture as snow and ice. These high-altitude glaciers became the ultimate source water, birthing the mighty Ganges, the Indus, and the Brahmaputra rivers. In the aftermath of a barren tectonic crash, the crumpled rock terraformed the entire region, creating an intricate, high-altitude ecosystem that sustains hundreds of millions of lives. We talk about the collision between India and Asia as if it is ancient history. It isn't. The crash is happening right now. The Indian plate is still driving its way into Asia at roughly 5 centimeters per year. That relentless pressure is physically forcing Mount Everest to grow about 1 centimeter taller every single year. But the rock cannot always absorb that movement smoothly. The friction builds up along the subterranean boundaries for decades, storing colossal amounts of energy until the rock finally snaps. When that tectonic tension releases, the results are cataclysmic. We see the direct, deadly consequences of this active subterranean engine in the 2004 Indian Ocean tsunami and the recurring catastrophic earthquakes in Nepal. The solid ground of modern India is an illusion. We are living our lives on the current frame of an unfinished, violent tectonic war.